Amides are our last functional group that we're going to look at in this topic, before we need to know about identification and all those sorts of things. We are going to learn about polyamides tomorrow and make nylon on Tuesday, so we are not done with amides after today, but it is our last functional group. So the key thing for us to know is, over here, when we worked together as a class to find these 5 plus others, these 5 isomers, they all have this CON inside them, somewhere. And so that is going to be our functional group. So we have a carbon chain, or maybe it's only a hydrogen, bound to this. Nitrogen makes 3 chemical bonds. Normally you'll see it as NH2, but there are times when this nitrogen is bound to other carbon chains. So you'll see it written in a multitude of ways. Okay, so we've got lots and lots of different carbon chains. This becomes important in one of the preparation methods that we're going to look at later. Okay, where different carbon chains can just keep attaching onto that nitrogen to make it go from primary to secondary to tertiary. We'll do that in another video. So, with 3 different types of functional groups, it's important for you to be able to recognise it very quickly, because you might have a primary, you might have a secondary, you might have a tertiary. And you can say, oh, that's an amide. So what we're looking for, as I put a box around over there, is this CON. And it doesn't matter what that nitrogen is bound to necessarily. So that's our functional group. Just for those who care about the geometry of these molecules, they always sit flat on a plane as well. They're all in a plane. So your bond angles are about 120 degrees around there. But here the R's are sticking out in 3 dimensions because you have got lone pairs of electrons here. Your primaries and your secondaries have a hydrogen bound to a nitrogen. Therefore they have the ability to form hydrogen bonds with water. Therefore their solubility is much higher than a tertiary. Tertiaries, it depends what the R groups are, and how big the carbon chains are coming off it, as to whether it's soluble. But it's most likely they'll be insoluble. With these two, because they've got an NH bond, so hydrogen bound to a highly electronegative element, nitrogen, they can actually form hydrogen bonds with water and dissolve. These ones, not so. Alright? So now you've seen that there's 3 different functional groups. It means that we must be able to classify them as either primary, secondary or tertiary. So just like amines, you're always looking at nitrogen as your central atom. So if your nitrogen has got 1 carbon bound to it, okay, so we're looking at this bond here, then it's going to be a primary. So if these 2 are hydrogen, so if we've got this, where there's only 1 carbon bound, then it's going to be a primary. So this is just like your amines. If I've got a carbon chain of here, for example like that, then I've got secondary and so on. So these ones are classified the same way as amines. I'll just put something up a little bit neater so when we've got the photograph of the notes it makes some sense. So this one here would be primary because there's only 1 carbon bound nitrogen. This one here would be secondary because we've got a carbon chain there and a carbon chain there. And so therefore you'd expect the last one to be tertiary because it's got 3 carbon chains bound to nitrogen. That is correct. Just like amines, we do the naming in a similar way. So if I look over here, I've got 4 carbons in a row, then CONH2. So I've got my biggest carbon chain is 5, so it's going to be pent. It's an amide, so it's simply just that, pentamide. Alright, so when I name it, I see this functional group, so it's an amide. So I write an amide. And it's got its biggest carbon chain, including that carbon. Don't forget that one. Biggest rookie mistake for amides. Don't get the carbon with the functional group on it. So 1, 2, 3, 4, 5 carbons, pentanamide. Now you don't need to put a number because just like carboxylic acids and acyl chlorides, this is the number 1 carbon. So that makes things get really interesting when you get down to a secondary or a tertiary. But I'll get to naming those in a minute. This one here, using that same idea, it's an amide because I see the C-O-N in it. So I write an amide, but animide is the suffix, so I can use the wrong thing. The largest carbon chain is 1, 2, 3, 4. And I'm putting the wee numbers there in my working. The reason for that is it's got a side chain, so I'm going to need to say where that side chain is. So 4 is bute, so it's butanamide. Then I go, oh, we've got a methyl group here, so it must be methyl butanamide. But actually, it would still be methyl butanamide if I put the methyl group here. So I need to specify which carbon it's on. I numbered this as my number 1 because that's the rules. So it's 2 methyl butanamide. Compare and contrast that with this one here, where again it's an amide, it's got 4, so it's butanamide, but 1, 2, 3, 4. This would be 3 methyl butanamide. Right, so those are the primaries, so actually quite easy to name if you can remember just the rules, basically. These ones are a little bit harder, so what I've done is put a secondary and a tertiary. There are many more amide isomers of this, of C5H11ON or NO, but I've just given a few here that we found earlier. So here, what I do first of all is I see which carbon chain includes the CON. Okay, which carbon chain actually includes that double bonded oxygen, and it's this one here. So it's got 1, 2, 3 carbons. So this is a derivative of propanamide. Prop, so prop's our 3. So this is something or other propanamide. Now just like in naming esters, I now go to the other side of it and go, what have I got? Well, I've got a 2 carbon side chain, as it were. 2 carbons is ethyl. So you'd expect it to be called ethyl propanamide. Nearly. Okay, nearly. What I need to also specify is that the ethyl group comes off the nitrogen. So it's in ethyl propanamide. So the ethyl group doesn't come off the pro part, it comes off the nitrogen part. Up here, of course, I don't need to write C-methyl to C-methyl butanamide, I just say methyl. It's inferred that if you don't put the N there, that side chain comes off the main carbon chain. If I put the N, it says that it comes off the nitrogen in the amide. Just like we did with using the N's for naming our amines. So what happens when we get something like this? Again, the biggest carbon chain with the carbon chain with the carbon oxygen double bond has got 3. So it's a derivative of propanamide. So I'm going to write propanamide down. Then I have a look, and there's a methyl group here and a methyl group here. So there's 2 methyl groups. So 2 is di when I'm talking about side chains, so dimethyl. And actually those 2 methyl groups could come off here, actually. So I have to say where they are. They're both on the nitrogen, so I have to say N, N dimethyl propanamide to name that. Saying that each of those methyl groups is not coming off the prop, it's coming off the nitrogen.
So if you had a methyl group that wasn't on, would you just put a number and then
Correct. So you go, for example, if that methyl group was there, you could, which is the number 2 carbon, you could say that it's N-methyl, 2-methyl propanamide.
Okay, so 2, 3, how you spell it?
No, it's N.
Okay.
Because the reason for that is we go, so N-methyl, 2-methyl, if it was that one moved on to the N. Okay, good question though. So the nice thing for you is you don't have to name these this year unless you're looking at doing scholarship, and then you do. Okay, so that's why I show it to you. You need to be able to name primary amides. Now the next video, which is going to be about preparation and hydrolysis, every one of you needs to be able to do that for level 3.